Now, here's a question that gets skipped in almost every robot demo. We spend enormous effort measuring whether a robot can do the thing. We spend far less measuring whether it will decline to do the wrong thing. When Google DeepMind shipped its latest robotics models at the end of July, it also published a benchmark aimed squarely at that gap. It is called ASIMOV Agentic, named for the writer who gave us the 3 laws, and what it measures is refusal, uncertainty, and asking for help. Let's dig in. The benchmark measures 3 distinct behaviors, and they're deliberately not the ones capability benchmarks reward. The first behavior is refusal, and the structure here is the clever part. The action model proposes something, and the embodied reasoning model has to decide whether to let it through. So safety is not a filter bolted onto the outside. It is one model supervising another inside the loop, and the benchmark scores how reliably that supervision holds. The second is recognizing that a task is not possible at all. Sounds mundane, but this is where a lot of embodied failure actually lives. A system that cannot represent impossible will keep trying, and a heavy machine that keeps trying an impossible action near people is not a harmless bug. And the third is proactive escalation, meaning asking a human when uncertain rather than guessing confidently. That is the behavior our training methods are worst at producing, because we spend most of the pipeline rewarding models for producing an answer. Measuring it separately is how it starts getting optimized. So why does this need its own benchmark at all? Compare what capability evaluation rewards against what this one does. A standard capability evaluation asks whether the robot completed the task, and that framing quietly rewards attempting. A cautious system that declines a genuinely unsafe instruction can score identically to a clumsy one that simply failed, which means the exact behavior we most want gets no credit at all. This benchmark inverts that. Blocking an unsafe tool call counts as success. Flagging that a task cannot be done counts as success. Escalating to a human counts as success. Once restraint is on the scoreboard, it becomes something labs can optimize and something buyers can compare instead of a paragraph in a safety statement. Now, this did not appear from nowhere. Trace how the ASIMOV line of work got here. The lineage starts with real-world injury scenarios rather than invented thought experiments. Grounding a safety benchmark in things that actually hurt people is what keeps it from drifting into philosophy. And it means the hard cases in the suite are hard for reasons that matter. Version 2 improved quality and, importantly, tail coverage. Rare situations are exactly where embodied systems break, because common cases are well represented in training data and the strange ones are not. Widening the tail is where a benchmark stops flattering the models it tests. It also added video modalities and embodied reasoning tasks involving physical constraints. Reasoning about what is physically possible from a video stream is much closer to how a robot actually experiences a room than answering a text question about a hypothetical one. And the agentic layer is the newest piece, arriving with the latest robotics release. It measures supervision between models rather than the behavior of a single one, which reflects how these systems are now actually built as a reasoning model watching an action model. All right, let's consolidate what this benchmark is for. ASIMOV Agentic is a benchmark from Google DeepMind for what it calls agentic safety orchestration and uncertainty resolution, shipped alongside its latest robotics model family at the end of July. Its core measurement is supervision between models. It scores whether the embodied reasoning model will refuse an unsafe tool call proposed by the vision language action model, rather than treating safety as an external filter. It also measures 2 behaviors that capability evaluations ignore: predicting that a task is simply not possible, and proactively requesting human intervention when the system is uncertain instead of confidently guessing. And the second version widened coverage of rare real-world injury scenarios, added video modalities, and introduced embodied reasoning tasks about physical constraints. If safety evaluation is your thing, we cover a lot of it over at standarity.com.